Hello and welcome to our new series. I know it might not be what you asked for, but I think we're going to have a pretty good show of it. And let's start talking about logarithms. Now, logarithms is a pretty scary word, but it is going to end up, and I promise you this, to be a pretty simple concept that we're going to get quite a lot of mileage out of. So we're going to open up this video with just the very basics of it. Why would we even want to talk about logarithms? And so to get into that, well, let's just recap where we've been. We've dealt a lot with different financial formulas. We've had the interest formulas, we've had annuities, we've had amortization. And obviously, we care about financial formulas because we care about finances. We want to manage our money well. And these formulas help track what we can expect in the future, what we can expect now for a loan, and they can be manipulated as well. So, one question I could ask would be, how much do I need to retire? For instance, suppose I've got such and such money in an IRA and I want to know how much do I need to invest in that in order to retire 35 years from now with a nice couple $1,000,000 to my name. And this is something we can answer both as a single investment, just dropping money right now and leaving it alone for 35 years, or as an annuity where we invest a little bit each month. So for the first one there, we use the compound interest formula. We know that R is 10%. I think I said that in the statement there. Obviously, it's compounding monthly, so N is 12. T is 35 years. A, the amount we want to end with, is $2,000,000. So the only thing we don't know is how much we want to put in now. So we can solve that. And we end up running our numbers and we get $61,000 to be the amount we need now to invest to have $2,000,000 35 years from now. And the value to that is pretty useful, right? It's good for us to know that in order for us to have $2,000,000 down the road, we still need to have quite a chunk of change now to get that ball rolling. And obviously, if you're anything like me, you probably don't have that money lying around. So you could either plan to work longer or you could work with an annuity. That's the other option here, where again, we have a lot of the same values. Actually, they're all the same. We just want M now, the monthly contribution. And so we're going to plug in all the numbers as we've done here and then just do some arithmetic, right? 12 times 35 is 420. 1 plus 0.1 over 12 is 1.083. Subtract the 1, basically crunch these numbers and then divide through, and you'll get the annuity you need to be $526 every month for the next 35 years. Do that for me, and you'll have $2,000,000 after 35 years. Of course, that's still asking quite a lot. But this is on the planning stage. What if we want to look backward? What if we want to work backward from where we are to where we want to be? So maybe another question we could ask is just, when can I retire? Right? Not how much do I have to set aside, but rather, for this amount that I have, when can I retire? So suppose my friend Bobbert has 20,000 in his IRA right now. It's growing faster than ours, right? It's growing 12% annually. So the question is now, when can he retire? And we're going to suppose that just like me, he wants $2,000,000 when he retires. Well, same formula, right? Compound interest. We've got 20,000 going in for P. We have 2,000,000 for the amount we want at the end. And oh wait, we don't have T. That's what we want, right? We want to know how much to wait until we can retire. And so we plug in our numbers and we end up with 2,000,000 is 20,000 times 1.01 to the 12T. I want to solve for T. How do I do that? Well, I'll go ahead and give you a heads up, right? I can't subtract, I can't divide, I can't take a root, I can't do an exponent, because that's how we solve things like x plus 12. That's how we undo addition or multiplication or x to the power of something. How do we solve 12 to the power of x? That's going to be what we're going to unpack this unit. And we'll start talking about that in the next video. I'll see you then.